So perimeter and area, you've heard these words thrown around, right? But what's the real difference? In this explainer, we're going to break down these two fundamental geometry concepts. One is all about the walk-around, and the other, it's the space inside. Let's jump right in.
Think of it this way. It all boils down to one simple question. When you see a shape, are you thinking about drawing a line around it, or are you thinking about coloring the whole thing in? That one little difference? Well, that's the key to everything we're about to cover.
First up, let's focus on that boundary. Imagine you're just tracing the edge of a shape, walking the line. Welcome to the world of perimeter.
Yeah. So perimeter is literally just the total distance around the outside of something. The source material gives a perfect analogy. Think of it like a fence. It's the total length of fencing you'd need to go all the way around a field. We're just talking about length here, a straight-up distance. And the math for this? Super easy. For a rectangle, you just add the length and the breadth together, and then you double it. And a square is even easier. Since all the sides are the same, you just take the length of one side and multiply it by 4. It's really just a simplified version of the rectangle formula when you think about it.
Okay, let's make this real with an example from our source. You've got a rectangular tablecloth, and you want to add a fancy lace border. So how much lace do you actually need to buy? This is a perfect job for our perimeter formula. And solving it is just a simple 3-step process. First, we grab our formula. Then we just pop in the numbers for the tablecloth. That's 3 meters plus 2 meters. That gives us 5, right? Multiply that by 2 and you get your answer. We need exactly 10 meters of lace. See? A perfect real-world use for perimeter. All right, so we've built the fence. Now, what about the field inside that fence? This brings us to our next big concept, area. Now, unlike perimeter, area measures the entire surface inside the shape. The paint analogy from our source is perfect here. It's how much paint you'd need to cover an entire wall, not just the trim. And that's why we measure it in square units. You're basically counting how many tiny 1x1 squares you could tile that surface with.
And finding the area is also really straightforward. For a rectangle, you just multiply the length times the breadth. And for a square, you just multiply a side by itself, which is why we call it squaring a number, side squared.
Okay, let's step it up a notch with a slightly trickier problem from our source. We've got a floor and we've got a carpet on it. The question is, how much of that floor is still showing? To figure this out, we're going to have to work with 2 different areas.
So the game plan is pretty simple. Find the area of the whole thing, then subtract the part that's covered. First, we get the total floor area. 5 times 4 is 20 square meters. Next, we figure out the carpet's area. It's a 3x3 square, so that's 9 square meters. The last step, just subtract. 20 minus 9 leaves us with 11 square meters of bare floor. Easy peasy. Okay, this is where things get really interesting. Now that we get perimeter and area on their own, let's see what happens when we put them together. It's kind of like a puzzle, and it's pretty cool. So I want you to really think about this for a second. Let's say you have 2 completely different shapes, but they cover the exact same amount of space. Their area is identical. Does that mean their perimeters have to be the same too? What does your gut tell you? Well, the answer is a big, fat yes. They can be different. And here's the proof. Check this out. Both of these shapes have an area of 9 square units. But look at their perimeters. The nice, compact 3x3 square on the left has a perimeter of 12. But the long, skinny 9x1 rectangle on the right, its perimeter is 20. Same area, but a wildly different distance around the outside. So what's the big takeaway here? It's that for a set amount of area, the more you stretch and pull a shape out of whack, the longer its perimeter is going to get. A compact, square-like shape is actually the most efficient way to enclose a space. It gives you the most area for the least amount of fence. All right, so since we're basically pros at rectangles now, we can use that knowledge to unlock the secret of another super common shape, the triangle. So let's start with what we already know for sure. The area of a rectangle is just its base times its height. We've got that down. But now imagine taking that rectangle and just slicing it right down the middle with a diagonal line from one corner to the opposite. What do you get? 2 identical triangles. And boom, that's it. That is the entire secret to the triangle's area formula. Because a triangle is exactly half of its matching rectangle, its area is just 1/2 of the base times the height. It really is that simple.
Okay, but there is one really important catch here, and it's all about the height. The height isn't just any random side of the triangle. It has to be the line that goes straight up from the base at a perfect 90-degree angle, making like a T shape. Get that part right, and you'll get the area right every single time.
All right, we have covered a ton of ground. Let's do a quick fire round of the most important ideas so they really stick with you. So here are the 4 biggies. Number 1, perimeter is the fence, the distance around. Number 2, area is the paint, the space inside. Number 3, and this is the cool one, the same area can have totally different perimeters depending on the shape. And finally, number 4, a triangle's area is just half of the rectangle it fits inside. Got it?
And hey, if you're thinking, I want to try this out for myself, our source material points to some awesome and totally free websites. Khan Academy, Byju's, Math is Fun, they all have great stuff to help you practice and really master these concepts.
So we'll leave you with a final thought to chew on, something that connects all this back to the real world. Think about that shape-shifting puzzle. If a city planner has a fixed amount of land for a new park, how should they design it? Should they make a long, skinny park to create a really long jogging path? Or should they make a compact square park to save money on fencing? It just shows you how these simple ideas really do shape the world around us. Thanks for joining me on this one.